Hello everyone, welcome to Chemical Engineering Educational Channel. In this video, we will walk through a complete numerical problem on simple distillation mass balance using a classic ethanol-water separation system. Here is the problem statement. We are giving the following data. The feed is 100 kg per hour. It contains 30 mole percent ethanol. The distillate product is richer with 85 mole percent ethanol, and the bottom product contains only 5 mole percent ethanol. So our goal is to calculate the distillate flow rate, then the bottom flow rate, and both in mass unit, that is kg per hour. Let's begin step by step. Step 1, convert mass flow rate to the molar flow rate. Since mole balance are easier for component calculation, so we first convert that feed mass flow into molar flow rate. For that, so we need to calculate average molecular weight in the mixture. So ethanol has, you know, that 46 kg per kilomole, means ethanol has molecular weight of 46 kg per kilomole, and water has 80 kg per kilomole. So the average molecular weight is equal to 0.3 into 46 plus 0.7 into 18. So 13.8 plus 12.6 is equal to 26.4 kg per kilomole. Now calculate molar feed rate. So that is F is equal to 100 kg per hour divided by average molecular weight 26.4 kg per kilomole. So that will 37.88 kilomole per hour. So this means we are feeding 37.88 kilomole per hour in the feed to the distillation column. Now going to the step number 2. So apply material balance equation. So we now apply two key balance. One is overall balance. So that is F is equal to D plus B. F is already know, that is 37.88 kilomole, and plus is equal to D plus B. So that is equation number 1. And then component balance for ethanol. So that is F into XF is equal to D into XD plus B into XB. So F is known, that is 37.88, and XF is also known, that is 0.3, and D is unknown, but XD is given, so that is 0.85, and B is unknown and XB is given 0.05. So that will be 11.364 is equal to 0.85 D plus 0.05 B. So that is the equation number 2. So in that two equation, so we have two unknown. So now solve that two simultaneous equation. So equation 1 and equation 2. From this equation, so B is actually 37.88 minus D. Substituting in equation 2, so we'll get 11.364 is equal to 0.5 D, and then we put that B here, so 0.05 into 37.88 minus D. Now if I do the calculation, so finally we'll get that B and D. So here B is equal to 26.04 and D is equal to 11.84 kilomole per hour. So our distillate flow rate is 11.84 kilomole per hour, and the bottom is 26.04 kilomole per hour. Now next we have to convert to mass flow rate. So now let's convert this molar flow back to the mass flow using average molecular weight of the each product stream. So for the distillate, which is 85% ethanol, rest will be the water. So average molecular the weight will be 0.85 into 46. So 46 is ethanol molecular weight plus 0.15, that is water percentage, into 18 is the water molecular weight. So if I do that calculation, molecular average molecular weight is 41.8 kg per kilomole. So now D mass we already got, that is 11.84 kilomole per hour. Now we have to multiply it with average molecular weight. So we'll get 494.9 kg per hour. Similarly for the bottom product, so in the bottom product 5% ethanol is there. So now we have to calculate the average molecular weight. So that will be 0.05 into 46 plus 0.95 into 18, so that will be 19.4. Now if we convert that bottom product mass, so 20, already we got that 26.04 kilomole per hour into multiplied by molecular weight, so that is 505.2 kg per hour. So here is the result summary. So here distillate flow rate is D is 494.9 kg per hour, that is 85% ethanol, and bottom flow rate B is equal to that 505.2 kg per hour, that is 5% ethanol. Now if I want to calculate ethanol recovery, so how will I calculate that? So how much ethanol is there in the distillate divided by how much ethanol is in that feed. So if I do the calculation, so ethanol recovery will be 89.5% in the distillate. Now if I check the mass balance, so we got that D mass is 494.9 and bottom mass, that is 505.2. So if I add that, we'll get nearly 1000 kg per hour. So means here that both mass and ethanol balance are satisfied. Now from here, what we did, we perform full mass balance and material balance, and then we learn that how to convert mass flow to molar flow, then apply overall and component balance, solve simultaneous equation, and then convert back to the mass. So finally we get the result. So if this video helpful for you, don't forget to like, subscribe and hit the bell icon for more videos on chemical process calculation. Thanks for watching.